Johnson, and this is my Lab 1 presentation. This lab introduced to me the concept of charge, which is a property of matter, and that there could be positive charge, negative charge, or an object that is neutral. These charges depend on the deficiency or buildup of electrons. I came to understand this concept through electrostatic fields on charged Scotch tape that I created. I created a U-tape which had a negative charge. This lab helped me understand the direction of electric forces after changes in charge and helped me calculate how much charge moves and helped me understand this through an example in everyday life. And the final result that I calculated was that there were 1.98 times 10 to the 11 excess electrons on the tape. Some fundamental principles and physical concepts that I used during this lab are the concept of polarization, which is when a neutral object interacts with a charged object or an electric field and then becomes a dipole, which is when charge separates within that object, creating an electric field. And now in this originally a neutral object has a temporary dipole and it is attracted to the other object. I also used the fundamental principle of charge, which includes the concept that two charges repel if they're like each other, and if they're different from each other, they attract each other. I also understood the concept of electric field, which is the electrostatic force per a charge, and that positive charges create a field that moves radially outward, and negative charges create fields that moves radially inward. And at the bottom of the screen are some equations that I used to calculate these fields. Some measurements that I used during this lab are the length of the tape, which I then used to calculate the mass of the tape, and I also measured the displacement of the floating tape. And using all three of these measurements, I plugged them into equations that I'll show on the next slide in order to calculate the gravitational force magnitude and the equal and opposite magnitude of electrical force on tape B, and finally the number of excess electrons on the tape. These are some of the equations that I used to calculate the previous numbers, and also a free body diagram demonstrating the equal and opposite forces of the electrostatic force from tape A and gravity on tape B, which created an equilibrium state. I also used these two equations to calculate the number of atoms on the sticky surface and the ratio of the number of electrons to these number of atoms. Some observations that I made during this lab were that when I moved my hand towards the tape moved towards my hand, which showed that the tape was negatively charged and then created a temporary dipole in my hand, and ended up attracting each other. I also saw that when I moved two charged tapes near each other, they repelled each other because they were both negatively charged. And I also saw the tape B when it was suspended in the air by tape A, showing that they had the same charges and repelled each other. Here is my code, which created the diagram on the right, which shows the two tapes and the electrostatic forces and gravitational forces acting upon them. And here are the equations on the left side of the screen showing the calculations of electric force and charge. I was also asked to answer these questions, including this first one, which is what is the magnitude of the charge on one piece of tape as calculated by my computational model. And I used the below equation to calculate that. It was 3.16 e to the negative 7 coulombs. And what assumptions or approximations did I use? I ignored air resistance. I treated the tape as a point charge with all charges concentrated at the center of the tape, and I assumed that the charge was evenly distributed along the length of the tape. Finally, considering what would happen if electrons had a positive charge and if protons had a negative charge. So nothing observable would change in this lab, except that the protons and electrons would move in opposite directions than they did in the lab because they would have opposite charges. However, they would still oppose each other and repel each other the same. And why is it important to handle the charged tapes as little as possible? And what happens when they come into contact with hands? So when they come into contact with hands, more charge is transferred from one object to another, and the tape ends up becoming less and less extremely negatively charged. So therefore, less extreme effects happened when I would try to repel or attract different objects. Thank you.